The goal of this project is to computationally identify vehicle number plates on vehicles, then convert the number plate image into text. Given an image of a number plate or a vehicle with a number plate, use computational photography principles to extract that number plate to text. Here's an example of some number plates and vehicles with number plates on them. And the computational part of this converts them into text. Right? Input image, computational steps, OCR. The pipeline we used for this is a main pipeline at the top, an alteration based on the image. If the input image is a number plate, then we used the main pipeline. All right, so we acquire the image on the main pipeline. We pre-process the image where we change it to grayscale, resize it, we turn the image into black and white so we can look for interesting aspects of the image. We do a small scale localize where we determine which part of the number plate is images that we need or characters that we need. We then segment these characters out using a scanning method, left to right, top to bottom, and a deep search for white pixels. Right. We cut these images up and we pass them to OCR. After they've been passed to OCR, OCR returns text to us. On the alternative pipeline, where we receive an image that represents a vehicle with a number plate on it, we have to pre-process the image, meaning that we change that image to black and white. Then we look for black squares or black parts of the image, right? And try and determine which one of these black parts of the image has the aspect ratio of a rectangle. That tends to be a number plate, which we then cut out and send back to the main pipeline and do the same set of processing where we change the image to black and white. We look for the parts of the image that's interesting. We cut it up into bits, into its separate letters, and then pass it to OCR. That is our main pipeline, alternative pipeline. Let me give you an example. Let me run through the code and show what happens when we do that. So what I'm going to do is I'm going to run through the Python code and show you exactly what happens at every stage. This is our debug window. Here we have an example of a number plate. It finds a number plate, pulls in the image, it changes it to black and white. It tries to find interesting parts of the image and then cut them out one by one. This is where it's searching. It takes a little while here. So right now it's searching for specific letters. It's searching for white pixels, which we call blobs of pixels. See, so it found New York. It found the 2, the F, A, S, T, 4, U. Sends these to OCR separately, and then it returns the actual text. See, too fast for you. We're gonna try another image. This is an image of a car. With a number plate on it. It changes the image to black and white, resizes it, looks for specifically the number plate. So now it's searching the entire image pixel by pixel to determine what are the interesting sections on the image. So it's searching for black pixels and then trying to find a set of pixels that are joined together that forms the rectangle. Found it. It determines that, okay, this is a rectangle, so most likely it would be a number plate. It changes it to black and white on the main timeline, and then it searches that pixel for that image for white pixels that should form letters. Finds them, cuts them out, and once again it outputs the text, which it saves to a text file. And that is our project. Let me just reiterate the timeline, the pipeline, sorry. It acquires the image, converts it to black and white and resizes it. It determines what are the interesting parts of the image, cuts out the letters, and finally sends it to OCR. Thank you very much.